Hello again guys and welcome back. In the previous video we configured VLANs in a Cisco switch and we explained that since the switch in use is a layer 2 device and routing is a layer 3 concept, it is not possible for the PC of VLAN 10 to communicate with the PC of VLAN 20 or the other way around. To allow for this interconnectivity, we will implement a technique known as router on a stick. Obviously, it's called router on a stick because it involves a router, which is what we're going to add to our lab, and plug the router from its first interface, Gigabit Ethernet 0, over to the switch's Fast Ethernet 024 port. We will fast forward the time, and the one modification that we need to make on the switch after we go into configuration mode is to go to interface Fast Ethernet 0/24, which is the port that we connected the router to, and then run switch port mode trunk. So unlike the other two ports that we configured as access ports, this port is being configured as trunk because this port will be passing information about the VLANs over to the router. So I will close the window, then I will open up the router, type no, enable conf t, and then we need to go to its interface of 0/0/0 and create a sub-interface of .10. Next, encapsulation .1q, which is the protocol that we will have to use, followed by 10, that corresponds to VLAN 10. And then we will configure an IP address of 192.168.10.1, followed by a subnet mask of 255.255.255.0. So this sub-interface will act as the default gateway for VLAN 10. We will exit out of there. And then we need to create a second sub-interface that will communicate, or that will allow communication, for VLAN 20. So interface 0/0/0.20, then IP address 192.168.20.1, followed by a subnet mask of /24 again. Oops. Okay, so I got an error saying only if it is configured as part of. Okay, so what I forgot to do is to run .1q 21st, and then perfect, the command with the IP address worked as well. Final change, we'll go into the normal interface to which both sub-interfaces belong, and we will run a no shutdown in order to bring it up and make sure that it's up and running. So we are done with our router. We will fast forward the time to make sure that the two network devices can communicate, and then as a final step we need to configure the network settings of the two PCs. So starting with the PC of VLAN 10, I will go to IP configuration and assign it an IP address of 192.168.10.10. The subnet mask of /24 is correct, so we will leave it as it is. And for default gateway, I will get to specify 192.168.10.1, which is the IP address we configured on the first sub-interface of our router, if you remember. That's done, and we will do exactly the same on the PC2 of VLAN 20. So over to IP configuration, we will assign it an IP address of 192.168.20.10. We will use the default subnet mask of /24, and for default gateway we will put 192.168.20.1, which is the IP address of the second sub-interface we configured on the router. Okay, perfect. So while being on the PC of VLAN 20, let's run a ping against the PC of VLAN 10 at 192.168.10.10, and provided that we have done everything correctly, it should work. So it's pinging the .10 PC of VLAN 10, and although the first ICMP request is failing, the subsequent 3 succeeded. If I run the same ping command again, this time it works to perfection, 0% loss. And to confirm that I can do the reverse, I will go to the PC of VLAN 10, navigate command prompt, and then ping 192.168.20.10. And we see that just like the PC of VLAN 20 can communicate with the PC of VLAN 10, so the PC of VLAN 10 can communicate with that of VLAN 20, thereby achieving inter-VLAN connectivity with the technique of router on a stick.